Okay, this is part 2, continuing from part 1 in my journey of trying to get audio working on my Zynq-7000 running Petalinux. So as a real quick recap, I have this custom board with a Zynq-7000 on it that I had put together. I have a connector that goes out to a little expansion, just a generic expansion card. From there, I'm running a bunch of jumper wires over to this little PCB. And this is intended to be a hat for a Raspberry Pi. And it just works out pretty well that it has pins on the top and it has a female header on the bottom, so I can connect these signals coming across from my main board. And then on the bottom, I also have a bunch of signals I'm tapping into with my oscilloscope, or a couple of oscilloscopes, so I can kind of see what's going on. And for me to use this, there are certain signals I need, and these signals that are pulled way out here are just the ones that I need to use. So there's an I2C pair of signals for controlling that codec. Then there are I2S signals, and there's 4 of them here. There's a clock, also called a bit clock. There's this clock down here. This is a left-right clock. And then there is also the digital to analog and analog to digital. So really 4 signals there that I'm using for I2S. At the end of the last video, I got to the point where I was in Petalinux, and anything I would try to do with it, I would get this write error, essentially some form of a write error. And in the video that I posted, video number 1 on this, you can kind of go back through that and kind of see how I went through and had built this this design in Vivado, and kind of talked through maybe some of the stuff I was doing in Petalinux. But I was stuck on this write error, but I was able to resolve that. In this video, I'm going to pick up kind of backing up a little bit and just kind of recapping all of the pieces I have, and I do have it working at this point. And so I'll just show you what I have so far. So this is in Vivado. This is my block design, and I'm zoomed out quite a bit here, but the main parts of this, there's the Zynq processing system over here. All of this stuff up here is for my HDMI output, which I will be using in this video, but I'm not going to get into the details of that. And then down here is everything I put in to support the I2S audio, to connect over to that codec and get everything working. And I have redone this a little bit since the video that I posted last time, video number 1. But to basically look through it, I have a couple of key things. So one, I'm using this audio formatter. I'm then using an I2S transmitter, an I2S receiver, and this AXI IIC. So the AXI IIC is basically my I2C, so that's the control signals for the codec. And then I want to transmit to that codec, and I also want to receive back audio from that codec. And the audio formatter is what kind of brings it in and lets me get access to memory and things like that. Besides that, I did bring out a separate one of these AXI Smart Connects for audio memory. I also did another one for audio peripheral. That really wasn't necessary. I don't think. I could have just tapped into the ones I have up here. But just to help me maybe mentally segment things a little bit, I brought out separate ones and hooked those in. But those are just smart connects to get me to my memory and this audio peripheral connectivity. But what I'm doing again is audio formatter, transmitter, receiver, these connections for this AXI connection, reset, and then also bringing my interrupts through this concat here into the Zynq processing system. And then I have a clocking wizard that I have set up. Now I did change fairly significantly from the last video how I'm doing the clocking. So in the last video I was bringing the really the master clock in from the codec board, that little hat, because it had a 24 megahertz oscillator on it. And one of the articles I was reading, someone was having problems using the Xilinx and what's in the Zynq-7000 to do the clocks. Ends up, I ended up scrapping that. So I have this clock in pin over here that I'm not using. And I just set up a clocking wizard. I'm bringing in the clock from my Zynq processing system, and that's 100 megahertz that I'm bringing into this. And then I'm taking out of it a 12.288 megahertz. And so if I open that up, you can see that it's pretty basic settings here. It's just an output clock. I'm calling clock out 1 for the output there, I guess. And then here's the clock port name I put on it. But then it's a 12.288 as far as megahertz for the speed. Then we come over to the audio formatter, and there are a couple important things here. It seems like, I guess what you can see here is I do have the audio read and audio write interface enabled. I am supporting asynchronous clocks. That's all default. The address width is 64 right now. I think for actually my system, 32 would be fine. I only have a gig of RAM, so I could drop that down if I wanted to. This interleaved or non-interleaved really doesn't matter for what I'm doing. I'm sticking with 2 channels. The memory data format, though, is quite important. So I did play around with AES to AES and PCM to PCM, and those just did not work. But if I do on the read PCM to AES and on the write AES to PCM, that is part of the recipe, I guess, that's working for me. And so that's how I currently have it set. And then on the, the I2C up here, nothing too fancy, just doing 100 kilohertz for the clock frequency for that, 7-bit address. You can see all these values pretty much are defaults. And I am running that off of a 100 megahertz clock going back to my processing system. And then on the audio transmitter, 2 channels, and I did drop it down to 16-bit. I don't need the 24-bit, and supporting the 24 or the 16 really isn't a big deal. I don't think one way or the other, but I'm picking 16 right now for simplicity. I don't, on this system, really need the 24-bit at all. I am not doing a 32-bit left-right clock. I'm just sticking with, it would be a 16-bit, I suppose. So 16-bit data, 16-bit clock to go with it. And then my receiver would be, matched up, same settings there. And then coming out of the transmitter is going to be a few things. So I've got my actual I2S clock or S clock, also called the bit clock. I then have the LR clock, so that's a slower clock that's just pretty much matching up with the sample rate, and I'm targeting a 48 kilohertz sample rate. So 48 kilohertz for that, and then the S clock out, I believe, is like 1.5 megahertz roughly, and I'll pull that up on the scope so you can see that. And it is dialed into what the spec says I should be running for those. And then I have the data out. This is the I2S data out. On the far left, I have an I2S data in, so if I want to record off of the little hat, it has a pair of microphones on it, I can do that. So those are the main things here. I did maybe mention one more thing on the pins I'm using for the clocks out of this. I was deliberate in which pins I used, and when it comes to those pins, I did pick, you can see for all of these, the I2C, and also getting into my clocks, I am using either an MRCC pin or an SRCC pin as I get into these, and that's just so they support they support clocks better, I believe, with was it less latency and jitter, whatever it might be, but those are preferred. And then on my data lines, I'm just picking a regular GPIO pin on the package. So that's what I'm doing right now for my audio setup. And that might not be so critical, but it seemed like as I was reading up on generating clocks from the Zynq, it's maybe better to leverage one of these. So I generated that, brought that into Petalinux, and in my Petalinux build, I found that the driver, if I can get that pulled up, I've got it over here. Here is the custom driver that I am currently at. So maybe I'll walk through this and just point out a few things in this custom driver that really were pretty important. So I'm going to jump down, and one of the important functions in this audio driver, there is a probe function. So when the driver is probed, it would run this function here. And that is not much different than I had in the first video. Maybe I've cleaned it up a little bit, but it hasn't changed a whole lot. But where I did spend a bunch of time was in this other function, this right here, this hardware params function. And this is where you need to set up clocks. So as I go through this, some of the first things I did is I had to configure the codec itself, and I told it that I wanted it to be a slave device. And so I'm generating the master clock really for all of the I2S communication from my Zynq-7000. And I'm going to basically feed in the bit clock and the left-right clock or LR clock from my Zynq over to the codec. Now the codec has its onboard 24 megahertz oscillator, but I'm not bringing that to the Zynq at this point. I'm just simply telling this that codec is going to be a slave device. That's what this first part is. I tell it then I want to do I2S for communication, and that I don't want to invert any of the clocks that I'm working with. So I set that formatting, and this is setting it on the codec. So it's basically writing to a register on the codec to specify I2S slave standard clock, no inversion on the clock. From there, I come down and I have to configure more on the codec, and this here is specifying to set a system clock, and I'm telling it that on my codec I want to just automatically pick a clock, pick 24 megahertz. So it'll use the oscillator coming in as M clock as the system clock for my codec, that hardware device. Then I continue down, and you'll see that I have another set system clock, but this is not for the codec. This is for CPU, which is my Zynq. So on the Zynq, then it's saying, okay, I'm using this audio formatter, and that audio formatter, I want to tell it how to set the clock. So I'm telling it that I want to output a clock at this rate of 12.288 that I was shown earlier. So that's the clock that I want to use coming out of the Zynq. Then you have to set up this divider and frequency. And so in my case, you have to pay attention. So if you're doing 16-bit versus 24-bit, that makes a difference. And so I'm doing a 16-bit data with a 16-bit basically clock to go with that, which if you do the calculations or the lookup, I think you're supposed to be at this 1.536 megahertz for the bit clock, or that main I2S clock. And then there's a calculation of how to get to that. And then the left-right clock should be really matched up to this 48 kilohertz, which is the sampling rate that I'm looking to use. But then you got to set the appropriate master or M clock ratio, which is 256 is what I'm using there. There's also a clock divider, and you can calculate all this. I just hard set it to 4. And then I come in here, and basically if I do those things, I come in and I say, okay, set the clock divider for my CPU, and I want to use this 4 as the divider. And then I come down here and I tell it that I want to set the clock rate, and the clock rate that I'm going to use is what was stored up here previously, which is the 12.288 megahertz. So this is really particular. If this isn't right, you won't get the correct speeds for your clocks, whether it's the bit clock or the LR clock. But this is the configuration I'm using. I do have an alternate configuration down here that's commented out, and this would let me do a 24-bit with a 24-bit data with 32-bit LR clock. And so that ends up being that you have to have a 3.07 3.072 megahertz bit clock, and then of course you'd still be targeting this 48 kilohertz LR clock, and this divider has to be a different number. Instead of 4, it's a 2, and that should give you the right outputs. And as I go through that, I do some logging, and you can see some of that logging I do as I go through this. But that took a little bit for me to get all this dialed in. So there was a bunch of just trial and error, and then just really reading up on what some of these calls are and making sure I'm understanding what the call is doing. Is it setting the CPU, or is it setting the actual codec? So that was something that you got to really pay attention to. So it's setting the CPU, or it's setting the codec. So if it says codec DAI, but I got through all that, and that of course builds fine, and then I build that into my Petalinux image. And maybe I'll now jump over to Petalinux. So I have a few things up here. Let me just see. I have this is up just simply showing me the I2 or I2C lines. So the I2C is used for control of the codec, and this is going to show me if I have any activity going on that. I also have a Windows machine sitting beside me that has a connection to my scope on it. And this connection is going to show 3 signals, and those are going to be my clock and data for I2S. So bit clock, LR clock, and the data out. And we'll be able to see any activity going on there. And I was already in the code, and Vivado, we saw that. Waveforms, we've got that. I then am also connected to my Zynq board through a terminal connection, which is this here. Plus I have, let me find it right here, the HDMI output of my Zynq board is what this window is capturing. So I have a little capture device, just a HDMI to USB, and that output is being shown right here. So I'm working on my Linux workstation. I have a separate keyboard that is connected to my Zynq-7000. If I show you a couple of things up here, I can come in and do like an ALSA mixer. And I showed this in the first video, and actually this, interestingly, is saying that connection refused. I'd have to see. I think it's because I do not have this user connected on my config. So let me just switch to someone else, and let me then try that again. So this is ALSA mixer, and maybe I will escape and go back in so it has the full screen. Okay, so this lets me go in and set volume levels, turn on and turn off outputs, whatever it might be, and I can arrow across. And I showed this in the first video, but I'm not going to use that, because over here, if I use my other keyboard connected to it and I use the HDMI output, let's see, I just make sure I'm the right person, Petalinux. If I open up ALSA mixer here, it looks much better. So this is what I'm going to use here. And I can see that my audio levels are not the way I want them. So I've got this set up so I can do an ALSA control, and I can restore my configuration for my audio. And I'll just bring this back up. So now I can arrow through this, and I'm going to probably start by turning down some of this, like my headphones. I'm going to turn the speakers all the way off for this video, because that'll just be noise in the background. And I'm going to turn my main volume down like so. And there's a bunch of other stuff I can work with through the rest of this, but that should be sufficient for now. Now, if I escape out of this and I go back into it, I can see that it's retaining those settings. So that's all good. Now, to test my audio, there's a couple ways of doing it. I can do a speaker test, So let's see, can I just clear the screen here, get this up top, and I'll maybe make this larger a little bit here. And I'll switch to these others, these other tools, this waveforms and this to see that better here in a little bit. But if I come over here, there is a speaker test, and that was one that I was trying to use last time, video number 1, and I'm going to tell it I want to do a 2-channel test, and that then runs a two-channel test, which is just a pink noise. So it's nothing very exciting to listen to, but it's a real quick pink noise test. Now, what I'm seeing up here, though, as I did that, I saw the I2C signals, and I can zoom into that and see both my clock, that would be the orangish color, and then the data kind of superimposed on it. So if you see activity happening here, it's the I2C control that it's working with. Then I can also come in here and look at this machine, and I have really the clocks and the data that I can look at as it's doing this. So I might get over here and just break out of that. And instead of doing that simple test, I'm going to do a play, and I can tell it what I want to play. And I've got some sample wave files I can play here, so I'll run this one. And I'm recording the actual audio on this other system, this Windows PC beside me, so I will edit that in so you can hear it here. But if I pull this up while that's playing, this is my scope. Ignore the little spikes, the over and unders. It's just because I've got long wires and not good connections to grounds, things like that. It's just a bad connection from my scope to my board. But it's enough for me to at least see what's going on as far as frequencies and such. So right now I have the very bottom signal down here is this bit clock. So that's kind of the main clock driving things, coming over to the codec board. This right above it would be this left-right clock, so that should match roughly the frequency I'm trying to sample at. And this top is the actual data that's being brought into the codec from my Zynq board. Now right now I have the trigger set on this channel 2, which is the, I'm going to set this to normal instead of auto, and I'll shrink this down a bit. But what you're seeing here, that this is 47.99918 kilohertz, and I was targeting 48, so that's about as close as I'm going to get, so I'm really happy with that. If I set my change my trigger setup, and I'll just simply go to the first channel, which is yellow, and I'll just get this up on here a little bit. You can see that that is 1.53597 megahertz, and that's pretty close to what it should be. Now I'll also put in, well, let's get my trigger back maybe to the second channel, and I'll just do a single, and then you can kind of see what this all looks like, and I'll spread this out. But so down at the bottom, you're seeing again that is my bit clock. Above that, you're seeing my left-right clock, and above that, you're seeing the actual data that is coming into that I2S board or the codec board. So that all is working fine. You know, the frequencies are looking good, and if I actually make a good connection from my scope to the board, you won't see those little spikes above and below. But you know, right now you're seeing that, which isn't a big deal. I'm going to go back to auto and just let this run. So I'm seeing good activity here. I'm seeing good activity here. That would be those really five signals that I have connected to the board. And jumping back over here, that would be here's my I2C, that pair of signals that I have shown up here. And then this clock is this bottom one. And then the LR clock is the second channel, the purple. And then the digital to analog is the top, channel 3. And that song finished, and so I'll go run it again. And then I can see all that traffic again. Now, maybe importantly, there was no write error here, which is great. So that's all working fine. Now, I probably did a little bit of configuring in Petalinux just to make all this work, and I can real quick run through maybe what are some of the things I did there. So I will maximize this. When I build my Petalinux, I just simply put in a couple of scripts. I got kind of tired of going through all the layer customization stuff. It was kind of a pain. So at least for now, what I did is in Petalinux, I have project spec, meta user. Now, of course, in modules is where I have my custom sound card driver. So that's what I showed earlier. And you can see I've got a lot of copies. I was backing up often as I went so that I could kind of see if I had an issue, I could step back a version. And I know version control would make more sense, but this is how I'm doing it. But there's my sound card driver. But then I also built an app that just copies miscellaneous stuff onto the Petalinux image. And so I got some sample audio files and I have some scripts. So I have one script that copies over an X11 configuration, which I still don't have running. I don't have X11 working yet with my video. But then I also copy over a configuration file that is used by ALSA, and that's really all of my audio volume levels, things like that. And then I also do this echo, which tells it to add my sound driver to this Etsy module so that every time I reboot, that sound card driver loads automatically. I know there's better ways to do that, but this is quick and easy, and didn't make me get into customizing my image too much other than this little script. And then the script then reboots. And then I have a second script that I can run that basically copies some files to my basically my home directory here, and then also creates a configuration file. There's this .asoundrc, and this is what I'm using for a configuration. So really simple configuration. Without that, a lot of the stuff I'm doing will not work. So that configuration has to be put in there. And then I tell it to restore from that previous ALSA configuration that was copied over, restore that for my current volume configuration. And so then over here, when I go in, and first of all, I can do things like go look at let's see, it'd be a sound, or let's see, RC, asound dot state. This is what is in that file. It's a pretty detailed file, but all I did is I had gone into ALSA Mixer, and the first time I went in, this was all kind of default values. It was everything was turned off or turned down. So I set it the way I wanted it, and then you can export all of that. And that I did. There's a command you can do, an ALSA control store. So like right now, if I like the configuration I have, I can do an ALSA control store, and probably have to do a sudo on that. But that stores the configuration, which I can then copy over into my Petalinux build if I want, and then it will restore that every time. Then to restore it, it was just also control, and it was restore, and that restores it back. But my script is just copying the backup file and restoring the backup file just to make things easier for me. And then I also have this other file, which is, let's just see here. There's this asoundrc. So really those two little scripts just help me. The first time I build an SD card and I boot from it, I run the first setup, it reboots, I run the second one, and everything's good to go. And that's been fine for what I've been doing so far. But again, if I go back into ALSA control, ALSA mixer here, I can adjust my headphones, I can adjust the speakers. Speakers are working plenty loud. And so that's good. And there's a bunch of settings in here I'm going to kind of play around with, the 3D stuff and some of this other stuff. But seems like there's a lot of stuff I can modify in the control of the audio. But with that all done, then I can come in here and I can do things like the speaker test. Tell it to do a 2-channel test. And there I get that pink noise. And as it's doing that, activity, of course, over here. Getting out of that, I'll break out of it. I can then also do my A play. That lets me play one of the WAV files, and I have a few different WAV files here. So if I look at that, these are the ones I have that I can work with. And so the first one I was just playing was this classical, and here I could play a little bit more upbeat song that is a 40 kilohertz wave. No, well, that's maybe playing in the background here as I'll edit that in. I've got some other files here just for testing. I have a 24-bit file as I was doing some 24-bit testing. Again, right now I'm set up with 16-bit support. I also have some 44.1 kilohertz files. The second one, rock.wave, is a 44.1, and there's also a 16-bit sample there that you can see. And it'll play those, but I notice there's a little bit of staticky with it when it first starts, and that's because my code isn't trying to dynamically change to support that perfectly. I'm just sticking with 48 for now. Yeah, I'm going to break out of that. Maybe I could also go in and say, well, I want to play this sample 16 Little Indian 48. Now, if I try to play, maybe there's a 44K version or 44.1. If I run this, you might have heard some of that static as it was playing. Or if I try to play the one that's just rock wave, that is again a 44.1. And so when it first started, you heard a lot of noise, but then once it got into it, it's maybe not so bad. But those are the wrong frequency, and I'm not doing anything to try to dynamically, convert those on the fly. I think that is something I can do with GST launch, but I need to play more with that. And actually, I haven't even tried that recently, so I think it's something like a GST launch. Now I believe, let's see, what did it have problems with? Probably a bunch of things. So resource not found, so I could have given it the wrong, that's not right. It's got to be, okay, so there I point it to this. Let's just see. I gotta point it to the correct file. I know, interestingly, it says it's playing it. I've got just a little earbud in my ear that should be the output of that. I'm not hearing anything coming out, so I'm not sure if it's using a different volume control or something else. Or I could maybe even come in here and try the 44. or just plain old rock. So I'll have to play around with that more. It looks like, oh yeah, failed to connect. So it's a connection refused. Now, I believe some of that is because you need pulse audio, and I do not. I've deselected pulse audio on the install, but there's still some remnants of it, and pulse audio I cannot get to run on this. It seems like, as I've been reading up on it, there are some issues with it on maybe some of the more recent builds, and I'm getting this smashing detected, and I think there's a patch for it. I haven't bothered trying to install the patch for it to resolve that. Something about 64-bit versus 32-bit references. I didn't get into the detail too much, but not too worried about that right now. But that's where I'm at, so I'm playing audio fine. My mixer's working fine. It would be great at some point if I could get audio with some applications other than, this A-Play or speaker test. For example, I might want to run Doom and have audio support. And I don't know if this FB Doom even supports audio. I know when I go to options, it does show sound volume, but it doesn't have any audio in it as I'm going. So that might be something else I can dig into later of should I be able to actually get audio support working with this. But right now it doesn't see it, or, well, doesn't connect to it. I don't have audio. So let's see, am I missing anything, I guess? Let me just take a look at my notes. So I left off with the write error in the last video. I resolved that. That actual write error was resolved with the custom sound card driver, me kind of refactoring that and really trying to clean that up. So that took care of that. Going back into, well, playing audio at that point, what I was finding was that the quality was really poor. I could kind of tell what the song playing was, but it didn't sound good. And at that point, I was doing PCM to PCM back in Vivado. And so when I came into this, I had it set to PCM on both of these, because one article said to do that, a different article said you need to stick with AES to AES. But in the end, it was this configuration you see here that finally got audio working fully for me. I had also experimented with, there's an updated codec for this, codec driver, I should say, for this specific codec hardware, the WM8960. I tried that, it didn't make a difference as I was troubleshooting going through all of this. It is kind of neat though, if I go back, to my actual hardware, the separate keyboard here, and I go into things like ALSA mixer. I can press F2 for system information, and I can, read, what is the version of all of this. So there's my ALSA driver version. I can go into my card and see there's the card devices. I see my playback, my capture, timers, and PCM, again, playback and capture with this WM8960. So that all looks great. If I hit F6, I can select my sound card, which, the default is my only card here, which is this one here. So then I can escape out of that. That does not work if you're simply connected with a terminal connection. But if I'm connected interactively with my keyboard and the HDMI output, I get to see those things. I will, when I get a chance here, like I said, in the coming days, I'll come back into this blog post and try to capture, I'll put a copy of the code I'm running for the custom driver, maybe a copy of these config files as I have them, or at least the details of the config file, which actually some of that is already in here, and any other details that might be helpful for those of you that are maybe going to try to, or interested in trying to get this little codec device working with your Zynq or some other system like that. I would say this is has been kind of a pain to work through, but now that it's working, it's kind of nice to have a little bit of audio, and now I can see if I can do more with that audio in the system. So if you got questions, comments, drop a line below in the YouTube video, and or hit up my webpage, my blog. You can also drop me a comment there or email me. I've got my email listed both in YouTube and on my blog. But I think that's it for now. So it looks like I'm going on 45 minutes here. Hopefully this was interesting, and kind of happy that I got to the point that audio is actually working at this point.